Veena is known as the waste queen. She is transforming the way in which we manage waste, not just in Australia, but across the world.
I see waste as an opportunity. To me, waste is really one of those untapped resources, just waiting to be harnessed. Here in Australia, we are sitting at that tipping point. We have seen the export bans on waste come about. We can no longer send it somewhere overseas and it then becomes somebody else's problem. We have to solve it. We have to do something about it.
Veena is absolutely obsessed with waste.
All of this polypropylene, easy to be remanufactured right here in Australia. This should not be wasted.
And you can see from some of the work she's done, she's completely steps out of the box to solve the problem.
20 years ago, she invented a way to recycle tyres into the steel-making process and saved millions of tyres from going into landfill. Now she's invented a new product that combines the textiles from old clothes with glass and turns them into a product for the building industry.
It's a paradigm shift. We have had the Industrial Revolution. We've now got this technical revolution. I think she's talking about a materials revolution.
So what you can see here is plastics and other waste materials. Some of this is destined for landfill, but we can use these materials as building blocks for making new materials, for new manufacturing, and new circular economies. Australia really cannot continue to assume that it's business as usual. And I think we need to be bold and brave and think big. My husband and my kids, they would absolutely define me as the mega hoarder. I don't see myself as a hoarder. I just see myself as somebody who's curious.
I think Mum had a few funny quirks that made her a little bit different to other mums. She was definitely the rubbish cop, really making sure if we were going to throw something, did it need to be thrown, could we use it?
Before I take the garbage outside, she'll make sure she goes through the entire garbage. Things like yogurt boxes, I just throw it, but she'll go and pick it up. We have a place in the house, I call it Waste Collection Center, and we got all kinds of stuff there.
You know, what I really like to pick out of garbage is all these exciting products that have potentially valuable materials in it. Like in this case, you can see this shiny metallic layer, and that's what I like to harness, and that becomes part of my collection. This is really how a lot of my research journey starts in all kinds of incredibly wonderful materials. So every time I collect enough of these materials, it comes with me to the office.
I've been working with Veena for over 5 years now at the Smart Centre, and it's always had a team of about 30 people, of passionate young engineers and scientists working in the space of waste recycling. Veena is the director, and keeping up with Veena is the challenge.
Well, hello.
Hello. What
Yes,
you bought for
got
us?
some goodies, right?
She will not stop talking about science and engineering and technology. It's from one idea to the next. It's part of everything that she does.
You've got, obviously, again, strong polymers.
The kind of materials that Veena's bringing in, they're either mixed in such a way that conventional recycling can't currently recycle it, or it's a material that people haven't valued.
Maybe HDPE and then LDPE for the cover.
I don't know how often I've opened up a chip packet and gone, this has got great aluminium in it.
Did you realise? Yeah, exactly.
The materials that we have collected here, we can see and understand the value that is locked up in these materials.
So I think someone needs to look at that.
Absolutely, yeah. No, I think that's potentially a good project.
Well, there's so much stuff that we just throw away and we just take it for granted. But, growing up in Mumbai, in India, where I was born, there was no such thing as a waste. Everything had value and everything had potential. Mumbai is a city that is the industrial heartland of India. Population of more than 20 million, and it's got an amazing buzz to it. You remember that I used to go for the yoga at, where was it? The one right on Marine Drive.
Keval Dam.
I try and go back to Mumbai about once a year and take my family with me. I'm one of 2 kids. Growing up, I was very close to my family, but particularly really, really very close to my mother. 5 o'clock in the morning, I remember we used to get up and you used to walk to the milk depot to go and get milk for the family.
Veena's mom was a doctor. She was actually a pediatrician. You know, her mom was working and looking after the house and doing everything. So that really inspired Veena a lot.
Sindhi curry, I remember, because you used to make it big. Sindhi curry is like, you know, I mean, you explain Sindhi curry, yeah. For my mother, it was absolutely anything is possible. Do what you love, but do it at your very best and be your best.
Ganesh, his name was Ganesh. He fractured his toe.
Oh my God.
Yeah.
Lucky you're a doctor.
Yeah, so I gave him straight away plaster. My expectation is that all women should be on the top. They should never be under any man. That's even today I'm talking for all women. And the poor people are starving.
Yeah.
And how can we afford to throw it?
My parents were absolutely the ones who inspired us to be curious about things. You know, as a kid in Mumbai, there is so much to see. And I'd see people working, repairing shoes, people carting all kinds of heavy things on their heads, for example. Old discarded radio, for instance, that they would feel that they could fix it and use it. Even today, there is a big part of the economy that operates off the back of repairing things. And how amazing is that? All these experiences that I had as a child growing up, I think had a role to play in what got into my system, into my DNA. Amongst my female friends, I was probably quite unusual in pursuing my love for science and engineering. As the only woman in the class, that was a bit isolating. By the time I graduated, I finished top of the class. Some of the male colleagues, I'm sure, were not entirely delighted.
I met Veena in Vancouver, Canada. We both studied metallurgical engineering, and Veena joined as a graduate student, just started her master's. That was a potential clash because I was absolutely a clean freak, but she was kind of a little bit messy because she just wanted to keep reusing things and I wanted to throw things.
Ram and I started to go out, and when it all became very serious, our parents were informed and they weren't too happy that Rama and I as students had really decided that we were going to get married. But the other important thing that bothered them was the fact that this was their role.
And a lot of the marriages in India are arranged marriages. I had to ask my parents for their permission. So I had to send them a photo. Veena had to do the same thing. Her parents actually tried to do some investigation to find out a little bit more about me. I guess they must have found something good. In the end, we got married whilst we were doing our studies.
So I came to Australia after finishing up my PhD in the States and eventually came to UNSW. Roundabout in 2000, I really got excited about researching waste materials as resources for steel making. People were too reliant on traditional coal and coke. No one was really looking at some of these other alternatives.
Around about this time, there was a growing awareness of the problem of plastic pollution. We understood that plastics don't break down, or they take thousands and thousands of years to break down. And Veena had this idea to take those plastic bottles that were starting to fill up the ground and the ocean, using them to replace coke, a fossil fuel, in the process of making steel. She called that idea green steel.
Karina, what we're going to do is we're actually going to be feeding in our plastic sample in there. And the idea is we want to be able to inject it into this furnace here.
I started working on the idea of using waste plastics in the lab. When the experiment started to work, it was exciting. You know, it's one thing to do these incredibly amazing experiments in the lab, but a whole nother ballgame when you have to actually take it out into practice, into actual commercially operating furnaces. So there was quite a lot of work to be done.
Hello, I'm James O'Loughlin. Welcome to the New Inventors. Tonight, 2005, I was hosting the New Inventors. On our panel tonight is Professor Veena Sahajwalla. Producers were looking for some more judges, and they discovered this woman who was an industrial innovator and doing some amazing work with steel and, in particular, green steel.
I was, approached by a producer. It was a bit of a surprise, and I was like, gosh, am I prepared for this? I mean, this is not my day job.
Veena, what do you think?
You've been very creative in using the operator's shoulder as a means to support the cam boom.
She always used to ask me after we'd done a show, or even in rehearsal, actually, how did that sound? What could I do better?
What are the advantages of your system compared to the others?
She was very humble, but Veena had a lot not to be humble about. She was doing amazing work and, in some ways, world-changing work. And then shortly after she joined the New Inventors, she won the Eureka Prize.
The 2005 UNSW Eureka Prize for Scientific Research, Professor Veena Sahajwalla.
A colleague of mine had to literally nudge me off the chair going, they've called your name.
Professor Veena Sahajwalla's research has shown the steel industry how to use waste plastic bottles to make steel. It's been a hard sell in a conservative industry.
The Eureka Prizes, they're really considered to be the Oscars of Australian science, and the one that Veena won is really the pinnacle of scientific achievement in Australia. Her invention was groundbreaking because she went beyond the traditional notions of recycling and reusing and turned the plastic into a resource. But the pressure was on now for Veena to demonstrate that she could make her idea work in the real world and commercialise it.
Now the time had come when actually the work of implementation at a steel plant had to happen. We had to work out where plastics would come from. We really needed an affordable, cost-effective source. Well, in Australia, each year, millions of these kinds of tyres end up in landfill. The rubber in tyres, like many waste plastics, is actually a really good source of carbon. So I remember thinking back then that this could be a fantastic substitute for some of the coal that could be used in electric arc furnace steelmaking to make green steel.
I was working at One Steel, Sydney Steel Mill in the early 2000s. The management were very interested in Veena's idea.
This is some of the material that you're...
Yeah, this is what we call our nut coke pile.
Plant trials demonstrated that rubber granules could be used as a replacement for coke. In 2011, the green steel technology was introduced to Sydney Steel Mill, followed by the electric arc furnace in Melbourne, and then taken overseas.
When the technology was actually getting commercialised, we were actually replacing more than a third of the coal-based carbon through waste tyres.
For a lot of Australian researchers, bringing their idea to market, the commercialisation of their work, can be the valley of death. There aren't many who make it through that and succeed. So what Veena had done was really special, and this enabled her to attract the kind of funding and support that she needed to get started with her Smart Centre.
After green steel, Veena started thinking about what other materials are out there that are waste materials but have value. Other complex waste materials, such as e-waste.
Well, e-waste is actually one of the fastest growing waste streams in the world. You know, we've got so many different types of electronics, you know, our computers, our phones, and of course, there's a lot of good quality plastics in there. And, you know, typically a lot of this e-waste plastics will end up going to landfill.
So Veena was able to develop a process that we could take those plastics, reprocess them, and produce 3D printing filament from them.
The plastics from e-waste gets fed into this machine. This then gets converted into plastic filaments, which are basically like spaghetti. And of course, these types of plastic filaments get used as a feedstock for 3D printing. One of the first products that we did 3D printing with was a pair of Gandhi glasses. And for Mahatma Gandhi's glasses to be that iconic set of glasses that everyone can recognize was something that we wanted to showcase.
Veena was experimenting with a variety of waste materials, and one of the most promising out of it was the combination of problematic waste glass and combining that with waste textiles.
So, you know, each year tons of clothes and curtains get thrown away. There's also a lot of glass that gets discarded, ending up in landfill. And I think for us, it was really about looking at really being innovative, doing a lot of experiments that allowed us to combine, you know, textiles and glass. But of course, as you can imagine, you know, not every experiment works and not everything is successful at the start. Some of these things actually didn't quite work. But after a lot of experimentation, of course, we ended up producing these beautiful green ceramics. And of course, these have got this amazing designer-like look.
She got to the point that she had a product that could be marketed. The next step was, how do we produce it and how do we take it out into the marketplace?
Veena really wanted to take an entrepreneurial route to actually get this product out into our communities and our homes, to be able to show that the science that's developed in these labs over many years can have real impact in our communities and solve real waste challenges. We started designing components and machinery, and that package we've ended up calling a microfactory. A microfactory is a series of modules that can take a variety of different waste materials and transform it into a new product.
This is the prototype microfactory for green ceramics. Textiles is one of the input materials that goes into making green ceramics. We combine our glass, textiles, and in our microfactory, this gets converted into a hard green ceramics. We are actually, with our microfactories, reimagining what manufacturing could look like in the future.
One of the ideas behind the microfactory is to really enable people and local communities to take control of their own waste. The ideal location for these kinds of microfactories is where the waste is being collected. Local councils, regional centres, so that you can really have communities able to access them and turn their own waste into a resource, into a small-scale industry.
We currently have a grant for commercialisation of our microfactory. We have to deliver, as part of the grant, we have to show that we're going to have a commercially operating microfactory that makes viable products. 2019 was really a big year for us because I got a phone call from someone at Mirvac. It was just amazing because here I was, I'd been reaching out to the building sector for a long time.
The building and construction industry contribute to 60% of waste in Australia, which equates to around 41 million tonnes a year. We needed to come up with a sustainability initiative for a particular project. So I went away and did a little bit of research. I was extremely impressed by the work that Veena was doing, and I just saw so many avenues that we could pursue.
I know.
The first project that Mirvac tested us out on was creating a few specific pieces. One of those was a dining table made from our waste glass and textile product. There were some side tables that were made from waste corflute banners that were collected here on campus.
When you've got orientation week and all of that and the banners come down, to actually see that in a real-world setting was really almost that sort of goosebumps, moment when you walk in there and you go, oh my gosh, these are our prototypes.
After our first project, we asked Veena if she'd come on board with something a lot larger in scale and much more ambitious.
We've now actually put in another range. It's gone into flooring applications, walling applications, and really all kinds of very creative applications. We consulted with the designers for the pieces here in this apartment, and most of the pieces are made out of glass and old clothes. Except for this particular designer wall, they actually wanted a softer look. So in addition to glass, we've incorporated jute bags. Jute is basically a plant, and jute bags are strong and sturdy, and they're used to store coffee beans.
I remember walking into the apartment and just being blown away by the variety of things that she'd been able to create out of what would have been considered waste materials, school uniforms and coffee bags and glass. We've just been looking for ways to expand and take it further and further.
We talked about creating our own microfactory on site so that we could create and produce green ceramics for our projects.
That's exactly what we've been looking at doing, is really taking people with us on that journey where they can reimagine themselves as manufacturers.
I've been running a recycling business in Cootamundra. It's a small town. It's about 4.5 hours southwest of Sydney. We mainly collect mattresses and tyres. We thought it'd be an easy process to recycle mattresses. We were a bit unprepared for what happens when you pull a mattress apart. You're left with lots of different materials. It's been a passion of mine to look at problem waste. So it was trying to unlock the value of that mattress once you've deconstructed it, and Veena was there to offer a guiding hand.
I met Andrew several years ago, and he was really interested in the work that we're doing in recycling, and started to show interest in our microfactories. Our first microfactory that's going to be up and running commercially with green ceramics is indeed now going to be at Andrew's site.
This is where we're assembling the microfactory, inside this smaller shed. A microfactory like this costs between $500,000 and $1 million, but this one's been funded by the university grant.
As part of the grant, we have to actually show that this microfactory is going to be running and ready, geared up, producing commercial products by about March. And that means we have to deliver. Well, we actually known Andrew for a while.
How long is that?
It's a few years now.
7 years, I think. It's
7 years,
yeah,
Andrew.
yeah.
Oh, my goodness, yes. We have been telling Mirvac about Andrew, and we've been telling him about Mirvac. So out of this, of course, conversation, new opportunities are emerging.
So we're redeveloping the old Channel 9 site in Sydney.
Yeah, that is so nice.
There are electronics, there's plastic, there's computers, there's desks.
That is polycarbonate, right?
It should be. There's a whole building full of materials.
This is the last one.
Waste from this site is going to Andrew in Cootamundra to a microfactory there.
This is really, really heavy.
The idea is always, of course, to be circular in the economy and to get the waste to Andrew and then hopefully buy the things back and we can use them in our development.
I brought back a ute load of material from the Channel 9 site. There was a bit of an Aladdin's cave in there. There's some really useful stuff there for the green ceramic tile, particularly this big black curtain that they use behind the stage. It was perfect for what we want to do. I'm conscious we're coming up against a hard deadline for a grant that the university received. Anaban and Keith have been tireless in coming down here and making sure we get the factory up and running. So the last couple of weeks have been very difficult, but the guys have put a lot of effort in.
Our whole team came down to Cootamundra today for a first major run of our microfactory. All set now. Okay. It's been a long journey, and I think there were lots of us in there today feeling really emotional. Fantastic. The time had really arrived for us to literally flick the switch. You're gonna have to.
Oh, no.
You're gonna have to switch
You
it on.
want to turn it on?
I know. You know, come on, Andrew. This is exciting. Okay, here we go. When we actually started producing the tiles, there was that sense of fear and also wonder as to what it might look like in this micro factory for the very first time. But what was absolutely awesome to see, that very first tile that came out of the micro factory was simply brilliant. That is great. And it was actually fantastic to see almost that look on Andrew's face.
There it is. That is amazing.
Well done, team.
Well done.
Yeah.
Andrew, who had really never been a manufacturer, he was now becoming a manufacturer. That's a big moment.
It is fantastic. Yeah.
The plan is from here on to roll out this and other kinds of microfactories across Australia so we can deal with not only our glass and textile waste, but also transform all kinds of problematic waste. Well, 2021 is, really looking very exciting. The first ever invention of mine, green steel, which is still going strong. And this year, Molycop has started using green steel in their facility in Newcastle.
Even though green steel technology has been around for over a decade, it's even more relevant today than what it was back in the 2000s, because our customers are demanding that the products that they purchase have been made from sustainable methods.
You guys have also been doing some trials, is that right? The next generation of green steel that we're working on is really about showing that we can push those limits. It's a great sign that you can actually show that we're bringing in more rubber into the process. Yeah. We're going to have more and more substitution of that coal with rubber tires to get to that ultimate complete elimination of coal.
Veena's playing a critical role, but it's going to take an army of people like Veena to solve our current challenges in waste.
In Australia, we have the skills and the technology to get to zero waste. What we need now is the will. We need the consumer will, we need the regulator and legislator will. And we bring all of those together, then we actually have the potential, I believe, to get to a zero waste economy, a circular economy.
You know, I am really confident that Australia can meet these challenges. When we start to see a future where people are going out and asking for resources and materials that come from waste streams, then I think we would see that we are at the cusp of that change. And that would be a really, really good thing when we're all inspiring each other to do things better.